Good evening, sir. How
Good evening. I'm good. I hope I'm
are
taking one
you?
name right.
Welcome, sir.
It's Kinza, right?
Yes, it's Kinza.
All right. So everything good? Understanding what is happening in 12th math?
No, sir.
No. So which chapter have you completed in school?
We completed continuity and differentiability, but nothing was gone in there.
All right. All right. So you have
Differentiability
finished
was
like
a bit understanding, but it's very hard.
right. I can understand that. Right. So you have completed determinant matrices, relation functions, and
Yes,
inverse
yes.
trigonometric functions and continuity differentiability, right?
No. Relations and functions we have not completed. Inverse trigonometry is completed. Yes.
All right. So did you understand inverse trigonometric function?
Yes.
All right. So everything is clear about that.
Yeah. No problem.
All right. So in the batch, we are starting that thing, inverse trigonometric functions. All right. So do you want to study inverse trigonometric functions today, or shall we start continuity differentiability?
As you wish, sir.
No, no, as you wish. This is a trial class for you. So if you find that more difficult, then let's start that.
Continuity is more difficult.
Right. So let's start continuity and differentiability. All right. So I don't like to teach continuity first in that chapter. All right. I start by teaching differentiation. All right. Why so? Because this chapter has three things mainly: continuity, differentiability, and differentiation. Right.
Yes.
So main portion is differentiation because we are going to need this thing in future also, like in future chapters also. Continuity and differentiability you don't need that much, but differentiation you are going to need in integration also, application of derivative also, right? So let's start with differentiation.
Yes, sir.
Are you
Yes, sir.
familiar with are you familiar with the basic formulas of differentiation?
Yes.
Sorry.
Yes, sir.
All right, so let me ask you: differentiation of sine theta with respect to d theta.
With respect to C theta.
D theta, like with respect to theta.
Cos theta.
Absolutely right. See, you don't have to think like a lot. They are going to take you like this only because they also know you know the differentiation of sine x with respect to x.
Yes.
So they are going to change the variable. But if you change the variable, let me call this y or z or anything. It doesn't matter, right? Sine x will be sine x.
Yes, sir.
So differentiation will always be same. And differentiation of sec theta,
Differentiation of sec theta is sec theta tan theta.
sec theta, tan theta. And differentiation of log x with respect to x,
Log x is 1 by x.
1 by x. Absolutely right. So this thing is clear.
Yes.
Differentiation of x raised to the power n.
Nx raised to n minus 1.
Absolutely right. Differentiation of e raised to the power x.
E raised to the power x.
Absolutely. All right. So basic formulas are clear.
Yes,
I
sir.
can test you in this, I guess. Right. So
Yes,
let me give you some more questions. Differentiate e raised to the power x sine x with respect to x. All right. This is your question to solve.
yes. E raised to the power x cos x.
This is the answer.
Yes, sir.
No, think about this again. See what you missed. Two functions are multiplied here, right? This is one function, this is one function.
Yes.
You get my point? What I'm saying you missed?
Yes, sir. Yes, sir.
All right.
I have to differentiate separately first.
Right. I hope you remember that U V formula.
Yes, sir.
All right.
It's e raised to x cos x.
All right. N e raised to the power x cos x. Anything else?
Sin x plus e raised to x cos x.
All right. Sin x and this. Right. So e raised to the power x you can take common. Cos x plus sin x is the answer. Right.
Yes, yes, yes.
So next question. Differentiate sin x upon x with respect to x.
Cos x cos x into x minus cos x into x minus sin x minus sin x. Yeah, minus sin x.
Slowly. Cos x into x minus sin x.
That's it.
So please tell me the formula for u by v form.
U by v is equals to u dash v minus u v dash.
Upon v square, right?
Oh yeah. Upon v square.
All right,
Upon x.
upon x square.
Yes, sir.
All right. So basic formulas are clear. This is all of class 11, right?
Yes, sir.
So what happens in class 12th? Because if they have told you everything in class 11, then why need to study in class 12? Because they did not tell you everything in class 11. What they like hide from you is there is something called explicit functions and implicit functions.
Okay.
Do you have any idea about this?
No, sir.
No. What are explicit functions? If you can separate y and x individually, all right, or another way of saying is this: if you can write y in terms of x, all right, y is equals to something. If you can say, suppose this is a question, 2y plus x square equals to 5, and what I can say, 2y equals to 5 minus x square, or y equals to 5 minus x square by 2, right?
Yes. Yes.
So this is explicit function. We have described y explicitly in terms of x. This is clear?
Yes, sir.
Is this clear? All right. So what will be implicit function? Take a guess.
In which y cannot be described.
Absolutely right. So what I can say, if I mention sine xy plus y equals to 5. Now, no matter how much maths you apply to this, you cannot separate this sine xy, right?
Yes. Yes, sir.
So they will always be together. So you cannot write y equals to something x. This is called implicit function. All right.
Yes, sir.
So we are going to learn how to differentiate these type of functions. In class 11, they have told you very simple things: differentiate sine x, cos x, e raised to the power x, and so on. But now we are going to learn about differentiation of complex functions. All right, a little bit complex, not a lot. So let me give you a question and see if you can solve this. All right, write down this question.
Yes.
2x plus 3y equals to sine x. Find dy upon dx. All right, I'll give you 2-3 minutes for this.
I got stuck.
All right. See how we can differentiate. Let's differentiate or write simply
Yes.
first. All right. So this
Yes.
is d by dx of 2x, d by dx of 3y equals to d by dx of sine x, right?
Yes, sir.
So if a constant is multiplied, we know we can take this outside,
Yes.
and differentiation of x is
1.
1 plus this 3 is outside, differentiation of y will be,
1.
so dy by dx equals to differentiation of sine x will be,
Oh, yeah. Cos x.
so we have 3 dy by dx equals to cos x minus 2. So this implies dy by dx will be equals to cos x minus 2 upon 3.
Yes.
All right,
Yes, sir.
absolutely clear, right?
Yes, yes.
All right, note it down, or shall we erase this?
Just 1 minute.
All right.
Done, sir.
Next question. 2x plus 3y equals to sine y. Right? Didn't change a lot. I just replaced x with y.
Yes, sir. Cos y minus 2 by 3.
Let's see. So this is 2 dx upon dy plus 3 dy upon dx, sorry, dx upon dx, 3y upon dx equals to d sine y upon dx, right?
Yes, sir.
So this is 2 plus 3 dy by dx equals to, what is the differentiation of sine y with respect to x?
Cos x.
Cos x or y?
You asked x. Now it's y. Cos y.
Cos y. But you have to multiply a dy upon dx also, right?
Yes.
Why so? The question is why? Sir, when you did for this sin x, you did not multiply, but now you are doing, right?
Our teacher told whenever y comes, just do one more dy by dx. She didn't say the reason.
All right. But there is a reason, right? You need to know the reason, otherwise how are going to solve like
Yes.
difficult questions. Why so? Before like going to that, we have to understand what is differentiation, right? Like this is a philosophical topic. What is differentiation? Can you tell me that? First of all, you are a science student, right? You learn physics, chemistry also.
Yes.
All right. So in physics, well, you must be seeing that everywhere is differentiation.
Yes.
So what is differentiation?
Definition.
Differentiation is differentiation, right? Absolutely. Apple is an apple, sir. What else can I say? See, differentiation says if I write dy by dx, then what this is saying, please tell me how much y changes when
Okay.
I put a very little change in x. All right. And how much little is very little? Very, very, very little. How much? 0.000000, as many times you can put 0 then 1. This in like very good English, they say infinitesimally small. You must have heard this in physics class. That means this is almost infinitely small, almost
Yes.
zero. All right. Before the x was 0.1, then it is 0.00000001. We added this number. So if I put that much change in x, how much y changed? That change is called differentiation. All right. Is this thing clear?
Yes.
Now, come to this thing that when we did this, then we directly wrote cos x.
Yes,
But
sir.
this is not the case. We write cos x into dx upon dx, and this becomes 1. Why? Because we are looking for change in x when we are changing x. So same amount will be change in x, right? If you put some change of 1 here, then this x will also change by 1. Yes or no?
Yes. Yes.
So this change will be 1. That is why we don't multiply this. But when you are differentiating sine y with respect to x, I don't know how y and x are related, right? They have not
Yes.
mentioned this. Then how can I say how much y changes with respect to x? I cannot. Then what I do is I find the change in y with respect to the change in sine y with respect to y first.
Yes,
All
sir.
right, because there is a direct relation here. Then I try to find the change in y with respect to x.
Yes, sir.
Now we can say this is cos y into dy by dx. Is this thing clear now?
Yes, sir.
All right. Or you can learn that whenever you have y, you can multiply dy by dx. All right. So this is dy by dx. Now you can put these two together and multiply that side. You will get the answer. All right, Kinza.
Yes, sir.
All right. Next question. And please, like, if you are not clear about this, then ask me again, because this is very important. We are going to do chain rule in future. You are going to need a lot of this.
Yes.
All right. So next question. Ax plus by square equals to cos y. Solved it?
Just 1 minute. Dy by dx is equals to minus a by 2by plus sin y.
2 how much? Minus 8 by.
Minus a.
Okay, let me solve this question. All right. So this is a plus 2b by dy by dx. So minus sin y dy by dx. So the answer will be dy by dx is equals to minus a by 2by plus sin y, right?
Yes, sir.
All right. Now, no doubts here?
No, sir.
Solve this one. All right, this is tan x plus y.
Y plus
I don't have the answer.
by 2y minus 6 square x.
All right. Let's see. I don't have the answer, so you can match the answer with
Y
me.
plus x or x plus 1.
All right.
Okay, sir.
This will be y plus x dy by dx. 2y dy by dx. Dx. So if we bring all of this together, so dy by dx will be equals to this minus this upon x plus 2y minus 1. This is the answer?
I don't know the answer.
You got the wrong answer. Let me check my answer again.
No,
This is
your answer.
one.
I did the same mistake again. Instead of for y dy by dx, I wrote 1. So
All right, all right. So very careful, right? Remember the
yes,
school teacher. Whenever you have y, dy by dx is a must. All right.
yes. I'll just copy it down for now.
Okay. No, don't. If you are copying down, then like write the between steps. All right. Don't skip steps.
Yes, yes.
Like bring all the dy by dx together, then this y to that side, and all of that. I can skip steps because I'm the teacher. All right. You cannot.
Yes, sir.
Yeah. They will not give you marks. All right. After this, we solve this question.
Yes. So
Yes.
is it equal to y square? The question.
And this is 42.
Okay, 40. Thank you.
Yeah.
Is one's answer minus 2x minus 2y by 2x plus 3y?
Let's see. 2x plus 2 times y plus 2 times x divided by dx plus 3y square divided by dx 0. So dy by dx is minus of 2x plus 2y upon 2x plus 3y square. It's not 3y, 3y square. All right.
Yes, sir. Yes.
So these are all like peanuts question, like very easy questions. This question,
Yes.
try to solve this one. But let me give you a hint. Do not just differentiate this type of questions. Whenever you see a bit complicated questions like this, right? What we need to do is first simplify, right? We are solving implicit and explicit types. So see if you can write y equals to something something x. If you can achieve that, then if you differentiate, then this will be very easy. Dy by dx equals to some function of x, right? Because if you directly differentiate, then you will have to differentiate this, then this, then this, then this, right? U and uv, and
Yes.
again, what is the issue? You have to prove that this is equals to this. If they had
Yes.
just asked, right, if they had just asked find dy by dx, then we can directly differentiate. But because
Yes.
of this, prove that this is equal to this, you have to simplify first. All right.
Yes, sir.
So try this. Otherwise, I will solve. No issues. How we can simplify? Any ideas?
No.
No. First, if we can take this to this side, other side, and then squaring both sides. Will that be okay? If I put square both sides, can I do that or not? Solve this, Kinza?
Not getting, sir.
Not getting. Let's see. So squaring both sides, we will get this is x square 1 plus y equals to y square 1 plus x. We can
Yes.
open these brackets. X square plus x square y equals to y square plus y square x. Right?
Yes. Yes.
Let's bring this to this side and this to this side. So what we'll have, x square minus y square equals to y square x minus x square y. Do you know this identity, a square minus b square?
Yes, sir.
What is that?
A square minus b square equals to a into b plus a plus b into a minus b.
Yes. So here x minus y into x plus y equals to, we can take xy common here. So we will get y minus x, right?
Yes, sir.
So we have x minus y into x plus y equals to xy into y minus x. See, this is x minus y, this is y minus x. If I cancel these, then I have to multiply a negative sign, right?
Yes, sir.
So I can write minus of x plus y equals to xy. This step is
Uh,
clear.
can you again explain this step?
All right. See, I can take this common outside a negative sign from this, and I can write y minus x into x plus y equals to xy into y minus x.
Yes.
So this is cancelled.
Yes. Yes. Yes.
All right. So multiplying this negative sign inside, Now taking the y to one side, we have xy plus y equals to minus x. So y
Yes.
equals to minus x upon 1 plus x. All right.
Yes.
So you can see it very complex thing became very simple. Now we can differentiate dy by dx as differentiation of this function. So find out the differentiation of this function.
Yes.
You have to apply this formula, right? U by v formula.
Yes.
All right.
Uh,
You're getting
minus
this?
is minus bracket 1 plus x by 1 plus x the whole square.
So not this.
Uh,
Because they've asked you to prove that this is equal to this.
the down by
Let me solve. So dy by dx, we have 1 plus x into differentiation of minus x is minus 1
yes.
minus minus x into 1 plus x. Did you forget this two negatives?
Yes.
All right. So you know where the mistake is. So 1 plus x whole square. So this is minus 1 minus x. This becomes plus minus minus plus. So plus x square upon 1 plus x whole square. This is cancelled. So this is x square minus 1. In fact, I am getting the same answer as you. Then
Yes.
did we commit any mistakes somewhere? Let me check. Or did I write the question wrong? I don't know. Give me one moment. XY. The steps are very clear. Nothing wrong in this. Plus x minus 1 minus.
So in the second step, we are doing the plus minus x. We are doing the differentiation of 1 plus x, right? So differentiation of 1 plus
Oh,
x.
sorry. I did not differentiate this. Thank you for that. I was telling about this, so I forgot differentiating. This will be 1, right?
Yes.
Right. Absolutely right. So this becomes plus x, and plus x minus x is cancelled. So minus 1 upon 1 plus x whole square. Absolutely right. Thank you for that. Otherwise, I would have gone crazy, right, to find the mistakes. All right.
Yeah, you know, I got the correct answer.
Yeah. So this is clear. Now the question you must be thinking, sir, how do we know like to go from this to this, right?
Yes.
Because sir, you have solved this question many times. That is why you know how to solve. But how can we do this? You also have to solve these questions many times. Not this question specifically, but many questions many times. Then you will build the intuition for mathematics, right? That what we can do. See how to think. We can easily
Sir,
see.
I
We
have.
can.
Yeah.
Sorry.
Yes. Nothing, sir.
All right. We can easily see that by squaring both sides, we can remove this under root,
Yes. Yes.
right? So I squared. Now I can see that if I multiply this, something common is coming and cancelling out. So I do all of this if I face a new question sometime. All right. So that is the way to think. And
Yes.
to build that intuition, you have to solve many questions. And I have been told that this class is for 45 minutes and the time is almost over. All right.
Yes, sir.
So
Yes.
whatever we did today is absolutely clear. This is a like good question. Please
Mhm.
focus on this. All right.
Sure. Yes, sir.
So this is all clear, right? No doubts in this.
No, sir.
All right. So this is the main portions of this continuity and differentiability. Continuity